Chapter 5, and I didn't have a time to set up the projector, but it doesn't work. So if it works, we are going to have the quiz, okay, for the chapter 4. And as usual, we are going to have the exercise lab on Wednesday. So let me have a couple of more minutes to set up this one. It looks like there's no signal. Send us. Okay, fine. When I applied college for my PhD in 2001, so I moved to the United States in 2002 and started my PhD. So just like you, I applied many universities to get the admission. So actually one of them was the Virginia Tech in Blacksburg. So, but my wife and me decided to go to the city area, so she wanted to do that. And you know the Blacksburg is one of the appalachian area, so it's just mining and nothing there. So I heard that, and I graduated. I got the PhD 2006. At that time, one of my friends actually applied together, and he got the admission, engineering school in the Blacksburg. So he actually did the PhD at the same time. And actually, he was 1 year after me. He got the degree. However, in 2006, April, there was a mass shooting by the student. So I think that he killed 30-something people on campus. Actually, he shoot the gun fire it's a nearby engineering building. It's actually engineering building, I think. So my friend said he was next classroom when the student shoot the gun. So at the time, number of victim is 30-something, but he said it may be possible in Blacksburg because in Blacksburg there's nothing there. So a lot of people actually the mental disease. Or sometimes stress and so on. But anyway, so I really thank to God. So not going to the Blacksburg, the Virginia Tech, then who knows. And 2012, so as you know, probably you may not know, so but you heard about the nearby, I live in Trumbull. The next Trumbull is Monroe, and the next town is Newtown. So in the Sandy Hook, one by the shoot in the Sandy Hook, the elementary school, 26 people died. One of them, the memory is in the Seaside Park to remember one of the victims, as the playground in the Seaside Park. You probably saw the Seaside Park, the playground. So then yesterday, so there is another catastrophe in Las Vegas. So far, at least 50 people died, killed during the concert. So I have a plan to visit Las Vegas the next month to attend the conference. people said Las Vegas is one of the safest city because of the casino. So it's actually not only the policeman, but also there might be, I'm not sure, so somebody like a gang or the whoever that control the safety of the area, but there's no other place safe from the gun. When you see in Connecticut, the student cannot bring a gun inside the classroom, but some of my colleagues in Texas, they are scared. It is allowed to bring a gun in the classroom. Okay, so that's another story, but no matter what happened, we need to go for the next chapter. So today we are going to talk about the process synchronization. So before we start, let me briefly So far we talked about the very brief introduction of the computing architecture. So what is a computer, how a computer is organized. That is the basic thing, basic understanding to learn about the operating system. Without computer architecture, there is no way to exist such operating system. Operating system definitely rely on the computing architecture. If the computing architecture changes, the operating system definitely changes. If you have new changes, the new hardware of your computer, so you should have the different operating system. There is no universal operating system. That is true. Then we talk about the operating system, the design and architecture, and that is basically the interface program between the computer and the user. And that interface program consists of the several parts that we have discussed. We can classify such the operating system. The role of the operating system as one is the process management, another one is the memory, third one is the I/O management. So we are going to discuss, we have discussed and are going to discuss about the three main categories of the operating system. So among such the detailed the responsibility of the operating system, the last few weeks we talk about the process. That is true. So whatever the responsibility of the operating system we discussed, that will be done, like the resource allocator, resource monitoring, resource the control, the coordinate. To implement such a thing, to do such a job, we need to create the process. So the starting operating system, that means we start the first process. Okay, the shutdown the operating system is to terminate all the processes. So all the activity on the operating system is related to the process. So because of that, process management is the most important part. So we learned about how to create the process and how to manage the process, and even including the thread we talk about. Because as you realize, the creating process is not the simple and the ignorable. So to reduce the overhead of creating process, we learned about the thread. So in chapter 4. So this is a process management. Then in the process management, also we talk about the not only just the long time ago, like the MS-DOS, there exists the single process, single job operating system. So if you run the command, that's all the thing that your operating system can do. But nowadays, it's a multi-job. If you remember the simple diagram, like the memory, so it's always then job 1, job 2. Job means it's usually task or the process. As we agreed at the beginning of the semester, so interchangeably I'm going to use the job, task, or the process. Job 1, job 2, job 3. So which means the multiple process are running concurrently. Also, some of the tasks, some of the job need the one or more the processes. So which means it's a cooperative process. So 3 processes are created and they are working together. So that means they need to communicate to each other. So for the communication, in addition to the creating process, for the communication operating system use IPC, inter-process communication. So for that in IPC, inter-process communication, there are different ways, either using messaging, queue structure, and the shared memory, or nowadays we are using client and server, CS, the socket program. So we can use such a socket program for the communication. Okay. So that means nowadays most of the operating system allow multiple processes are working together. Okay. Then because of this one, there's something that happened which is not expected. The result. The simple example is, for example, shared memory. So we have the 2 processes. Okay. Then luckily we have the 2 CPU. So CPU 1 and CPU 2. So obviously, if this is SMP, the symmetric massive process, the operating system consider use the multiple processor. Then in case the 2 processes are running, they can assign 1 process per the CPU. So we have the 2 process 1 and process 2 is running. They are working together, which means we have the shared memory. So for example, so this is the simple computing architecture. So shared memory architecture. We have a multiple processor, CPU, then they are shared. Like your PC, most of your PC that has a multiple processor, multi-core, so it's a shared memory architecture. So we have the memory. So let's suppose that we have the simple job, the shared memory. At the I value is 0. So this is a 5. Same as the later. The 5. The process 1 is always the minus I minus 1. It's always reduced by 1, decrement. And the process 2 always is an increase I plus 1. So, however, this is a high-level language. By the way, anyway, so before we talk about this one, what happened when you run the process 1 and process 2 running together, execute the same time? What's the result of the I? Can be the result. 5, 6, 4. Don't care. So it can be 5. For example, I read the data I from the shared memory. So right now it's a 5. At the same, right after that, so or same time, you can read the 5. It may be possible. Reading is not a problem. Okay. Then this one is decreased by 1, so it's going to be 4. This one is just 6. Okay. Then you can update. You can update this one 4. Then update, write this data 6. So finally, it's going to be 6. Also vice versa. So if the process 2 write the data 6 and then followed by the process 1, it will be 4. So 6 may be possible and 4 may be possible. Also, the process 1 read the data first, then minus 1 and update. It's going to be 4. Then read by the process 2. This is a 4 plus 1. This is a 5. So final value or vice versa. Read, update, read, update. It will be either 6 or 4 or 3. Okay? Is it okay? If it's not okay, this is something unexpected result. So we cannot guarantee. Okay, sometimes the process run may be faster than the other, or the vice versa, so we cannot guarantee the result. So this kind of the problem is called synchronization problem. It's not synchronized. So this condition, usually when you have only one process and one sequence of instruction with the data, there might be no problem, right? Only you are able to update or change the value. Only one process. When you have the one process, there might be no problem, okay? Only when you have multiple processes, 2 or more processes are running concurrently, it may be a problem. Also, if CPU 1 has their own memory data, CPU 2 has their own data and separate, they are not sharing the data, then there might be no problem. So you can update your data, you can update your data. So this synchronization issue will be happen when you have multiple processes plus share the data. Then this is called race condition. Racing, compete each other. Race condition. So in case of race condition, then it causes synchronization problem. So this is a huge problem actually in not only operating system but even your application program. So I probably mentioned that. Yes?
Is it still a problem even if they can't write to the shared data?
If they cannot write the shared data, there might be no problem. But when they share the data and write over, then it will be a problem. Right? So this one is not only the problem of the operating system, but also your application program. Like the thing called thread programming. So I'm going to create the thread, the 5 threads. So 5 threads are running, then they should access the global variable of the program, the main program. Okay? Then whenever you update the data, you cannot guarantee the output. So synchronization is not only the server-side problem. Any application have the synchronization problem. So I probably mentioned that when I had a meeting with the Priceline.com, the CTO, he usually try to find the application developer who understand such a thing because it's critical in their system. The Priceline.com is not travel agent. It's kind of their client are the travel agent. So collect all the resources of the ticket or the booking system, and sometimes from the train, sometimes from the airplane. The 100,000 of the agents. Some of them are using the system, like the very simple, but the others are very old. So the heterogeneous source of the data, sometimes they are dealing with the airplane ticket. So it will be conflict. It will be definitely the synchronization problem at the race condition. So they need to solve it in their application program. So always but you may not realize so far. So some of them already realize, but may not realize such a synchronization issue. Why? Your program language already handle inside their programming language or the library, they handle such a race condition synchronization problem. So in this chapter, we are going to see what is the synchronization problem, then how we are going to address such an issue. So there are different ways to solve the problem. So basically, software solution means we are going to use algorithm logic to address this problem. So another one is hardware problem. Hardware means what? CPU, the instruction. Okay, hardware. So in your program, it's not based on the logic. Instead, we are going to use such a hardware. So when we are saying the hardware, that means the CPU instruction. Then also we can use the operating system. Actually, it's also because the operating system itself is a software, it's a part of the software solution, but the operating system provides several data structure. So we can use such a data structure. So in chapter 5, we will see such a solution of the synchronization. But I usually, I'm not sure whether this is the best example to explain about such a synchronization, but I usually use the advising or going to the bathroom to explain about the synchronization solution. But to do that, before that, so first we need to define what is the value. So in case of race condition, so we are going to call this the condition called the synchronization issue. So in terms of data structure, so we have a process. So process is what? It's a series of instruction, set of a sequence of instruction running on the memory. Okay, this is the process. So some of the instruction does not cause any, do not cause any race condition. Only few of them, not few of them, I'm not sure the few or the many, but some of them cause the synchronization. Especially when?
Changing the value or assigning the value.
When we access the shared data. Okay? So if the sum of the instruction cause, not always cause, may cause such a synchronization issue, or in other words, race condition, in other words, accessing shared data, then we are going to define this set of instruction as the critical section. Critical section. So this set of data as a critical section. Then this set of instruction may cause such a synchronization problem. So we need to address that. So before we enter the critical section, just before we are going to add entry section. And if we complete the last instruction of the critical section, we are going to call this is the exit section. The others will call remainder section. So which means we are going to define the process by the four sections. One is entry section, another one is critical section. If we exit the critical section, that is the exit section, and the others are remainder section. So operating system or your synchronization solution add two parts. We have originally the sequence of instruction. Some of them cause the synchronization problem, the others are not. In case the instruction causes the synchronization problem, then that is called the critical section. So before we enter the critical section, we are going to add entry section. Then we are going to add another section when we exit. That means, think about I'd like to go to the bathroom. How many bathrooms? We have only one bathroom. Okay, it's a critical area. Then how many people are sharing there? So maybe 10, all students sharing one. Okay. Then if all the students would like to use the bathroom same time, maybe possible. Sometimes my son and me use the bathroom same time, in case in a hurry, but usually not. So we are going to consider such a bathroom. Using bathroom is a critical section. So what will be the solution? So we can put the key outside, for example. So we are going to put, this is the bathroom. So there's a key. So outside. So when you enter to enter the bathroom, to use the bathroom, what do you need to do? Pick up key. If available, okay, there's only one key. So that is entry section. Okay, if you get the key, or if you acquire, or what if there are many people you can line up. Okay, so somebody may organize the line. Okay, then one by one you can get. Or in case even though you have the 2 bathrooms, but if there's many other, so once you get the key, you can access the bathroom. This part, getting the key is kind of, it's not the solution, there may be the one solution, but you will see. Getting the key not always the best solution. We will see, but it's just a simple example to understand what is the entry section, what is the critical section, what is the exit section. Then, once you done whatever you did, okay, then when you exit the bathroom, you need to return the key. Then somebody can use. So, returning key is for the exit section. Okay? But, so, I have a very close friend who are waiting outside. So, but he is the end of the line. So, you can give the key to your friend. Right? That may be possible. It's not fair. Or it's fair. Anyway. So, you can give the key. There might be different ways to exit when you exit the, okay? Or you can find someone who is really in a hurry with the desire to use this one. So you can select the next one, or there might be 14 among the group who are waiting. So that is called the exit section. Okay. So then we can understand. But the other, when you go out, you are not related to the using bathroom. That is called the remainder section. So we are going to consider changes slightly data structure of the process. Process we learn is a sequence of instruction. However, in case it causes the synchronization problem or the race condition, or simply when you access the shared data, if you are accessing not shared data, like I have a private bathroom, there might be no problem, right? Do you have a key in your house for bathroom? Probably not, because it's dedicated, it's not shared. So at the time, we don't have to worry about it. However, in case access the shared data, so when you use a public bathroom, you need to get the key, kind of. It's an entry section. Okay? Then, when you are done, we are going to do something. It's the exit section. So mostly entry section is like what? Selecting the process, next process to access the critical section. This is not the only process. There might be another process that try to access the same bathroom. It's a shared data. Same shared data. That has the same data structure. So entry section, critical section, exit section. Okay? Then the others are remainder section. Okay. So we are going to find the solution of that. So what is the simplest way? I already mentioned. You can use the key. Okay? But depending on the key, depending on how to give the key, you can use this one, but what about the key itself? Key itself is also shared data, right? That is also shared data. So we need to think about the precisely define the data structure to solve that problem. So let me for your better understanding, I'm going to use the slide. Okay, that's the idea. There are so two. By the way, what is this? The exit section and entry section. It's the code, algorithm. Okay, so we are going to say first. I'd like to show one of the example of that. Then we can go back and understand. So this is the process. The structure to address the synchronization issue, entry section and critical section, the exit section, remainder section. So operating system, we would like to add the entry section and exit section to the existing process. Okay, and this is one of the simplest example. So we turn is the key. Okay, whose turn? to enter critical section? Whose turn to enter the bathroom? So that is the J. Then once, think about the while loop. This is the infinity loop. Until when? If turn is J, it will be keep running, which means it cannot enter the critical section. Okay? Then, so let's say this is the I, this is the J process. So why? Turn is J. So currently the J is using. Okay? J is using the bathroom, which means turn is equal to J. Okay? That means this one may not enter critical section. Until when?
J releases.
This one exit is turn is I. Because this is the process I. So this is a process I. The process J has the turn is the I. Okay? So when the J exit the critical section, the turn value is changed into the I, which means this process J's I side is a false. Then exit the while loop, enter the critical section. Okay? So you don't have to worry about right now. This is because I realized that many of the students are confused. What is a really entry section? What is a really exit section? It's a program. So logic to control whose turn. So this is the simplest way to implement such a synchronization solution. Okay. So later we will see the more complicated solution. First, I'd like to show some of the example. Like this one. This is the entry section. Logic is slightly the complicated, but idea is the same. So entry section, select and decide who's gonna use the bathroom. Then why the critical section is the one when the process leaving the critical section, it will set something changing to decide next process. So we are going to see such an algorithm of the synchronization solution. Okay, let's go back to the beginning. So race condition is two options, two the requirement. One is multiple processes, several processes access the shared data. At that time, it calls the race condition. So when we define the critical section, so operating system should know which one is the critical section, which one is not. At that time, simply when a process would like to access the shared data, then we will consider this may cause the synchronization. Then we can use the entry and exit section. Okay. So to understand such a thing, I think the last time I didn't explain the details, but when we encounter something problem in not only operating system but any computer science, we are going to model